Welcome from Nexus. If you're planning a career in tech, you already know data is pretty much everything. But here's the thing. Over the last couple of decades, the whole world of data has been completely turned on its head. So today, we're going to break down the very first chapter of Big Data for Dummies to really get a handle on the fundamentals. All right, let's jump right in. We've hit this incredible tipping point. The sheer amount of data, the speed it's coming in, and all the different types of data streaming from social media, sensors, you name it. It's just become way too much for our old systems to handle. And this isn't just about having more data. It's about a totally new kind of data that's forcing us to rethink, well, everything. So in this chapter, here's our game plan. We'll start by looking at the history and what got us here in the first place. Then we'll define what big data actually is, using this really simple framework called the V's. From there, we'll check out the architectural blueprint designed to handle it, zoom in on the core technologies that make it all work, and finally, we'll tie it all together and talk about why this is so critical for you. Okay, so let's talk about this new era. We've made this huge shift, you know? We used to live in a world where data was all neat and tidy, organized to answer really specific questions like, how many products did we sell last quarter? Now we're in a world where we have this massive, messy goldmine of information. And the real challenge has become, how do you even begin to find the nuggets of gold hidden inside all that noise? What's so cool here is you can see how each new technology was born directly out of the limitations of the last one. Back in the 70s, the relational database was a total game changer for managing structured data. By the 90s, we had so much of that structured data that we needed the data warehouse just to make sense of it all. But then the 2000s came along, the web exploded, and we were hit with this absolute tsunami of unstructured data, text, images, video, that our existing systems just weren't built for. And that, right there, is the problem big data was created to solve. So to really get a grip on the solution, we first have to put some words to the problem. The industry came up with a really simple but super powerful model to do this. It's known as the V's, and it helps describe the main challenges of big data. First up, we've got volume. And we're not talking megabytes or gigabytes anymore. We're talking terabytes, petabytes, even exabytes of data. Just try to imagine the weblog data from a site like Amazon for a single day. The scale is absolutely mind-boggling, and it just completely dwarfs what a traditional database can handle. But it's not just how much data there is, it's the velocity. This is all about the speed of the incoming data. I mean, it's a ton of data, and it's coming at you fast. Think about a Twitter feed during a major world event. You can't just wait around and process that stuff overnight in a batch job. You have to analyze it the second it happens to find anything useful. So you have massive volume coming at you with insane velocity. And to make things even crazier, there's variety. Big data systems can't be picky. They have to deal with everything from perfectly organized database entries to semi-structured things like JSON files, all the way to completely unstructured stuff like customer emails, audio from call centers, photos, and videos. It's that messy, chaotic mix that makes this such a tough nut to crack. But even if you can somehow tame the volume, velocity, and variety, there's a fourth V that can trip you up: veracity. This is all about trust. How good is your data really? With information pouring in from so many different places, how do you handle things that are inconsistent or inaccurate or just plain wrong? Veracity forces us to ask the big question: can we actually trust our data to give us real answers? All right, now that we've used the 4 V's to frame the problem, let's get into the solution. This section is all about the architectural blueprint that makes it possible to manage big data. So you're getting hit with massive volume, high velocity, huge variety, and you're not even sure you can trust it all. How on earth do you build a system for that? You can't just buy a bigger server. That's not going to cut it. You need a completely new architecture, one that's designed to be distributed from the ground up. And the solution is this layered architecture that you're seeing here. The best way to think about it is like a stack. Down at the bottom, in layer 1, you have your physical hardware. Right above that, you have the brains of the operation, the tools that organize and manage the data. And then at the very top, you have the apps that people actually use. Let's start at the bottom and work our way up. Layer 1 is our foundation. And here's the absolute key to the whole thing. It's a distributed computing model. Instead of one giant, super expensive server, you're using clusters of much cheaper off-the-shelf computers. This whole foundation is built for redundancy, and it uses APIs to pull data in from everywhere, from your internal systems like a CRM to external sources like a social media feed. This is the bedrock the whole system is built on. Okay, so we've got the foundation poured. Let's move up the stack to layer 2 and pop the hood. This is the real engine room of big data, and it's powered by a few absolutely revolutionary technologies that changed everything. The first major piece of this engine is MapReduce. Google came up with it, and it's basically the divide and conquer strategy for data. The map step takes a huge, impossible problem, breaks it down into thousands of little pieces, and hands those pieces out to all the computers in the cluster. Then, the reduce step gathers all the little answers back and combines them into one final result. It's how you can process petabytes of data without waiting for years. So MapReduce is doing all the heavy lifting, but you've got to store all that data somewhere, right? That's where Google's Big Table comes into play. It's a massively scalable distributed storage system. Think of it as a non-relational database that's specifically designed to manage structured data across thousands of regular servers. It was built for huge scale right from the very beginning. Now, Google pioneered these amazing ideas, but they were kept in-house. The real game changer for the rest of the world was Hadoop. Hadoop is an open source framework that basically took the core concepts of MapReduce and distributed storage and made them available to everyone. It's the thing that really democratized big data and put all that power in the hands of developers everywhere. Okay, so we've gone through the history, the challenges, the architecture, and the core technologies. But let's bring it all home. What does this actually mean for you as a computer science student getting ready to start your career? This isn't just some abstract theory. This whole stack is your professional toolbox. Seriously, whether you end up building recommendation engines, analyzing IoT sensor data, or training massive machine learning models, these are the fundamental concepts and tools you're going to be working with every single day. Understanding this architecture isn't just nice to have, it's absolutely essential for building modern software. So, we've laid the groundwork. We get the why and the basic how of big data architecture. But remember that tricky V we talked about earlier, variety? How do you really deal with that messy, chaotic, diverse new world of data? Well, in our next explainer, that's exactly what we're going to do. We're going to dive right into that chaos. We'll examine all the different types of data, structured, unstructured, and that weird stuff in the middle, semi-structured, and we'll figure out how to turn all that raw information into something truly valuable. I'll see you then.